Sir Isaac Newton's three laws of motion, which were first described in 1687, form the basis of classical mechanics and are essential to understanding the motion of objects. These laws describe how objects move and how they respond to forces acting upon them. The first law, also known as the law of inertia, states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with a constant velocity, unless acted upon by an external force. This means that if an object is not being pushed or pulled, it will remain stationary or continue moving at a constant speed in a straight line. The second law, also known as the law of acceleration, states that the rate of change of momentum of an object is directly proportional to the force applied and occurs in the direction in which the force is applied. In other words, the greater the force applied to an object, the more it will accelerate. The relationship between force, mass, and acceleration is described by the equation F equals ma, where F is the force applied, m is the mass of the object, and it is the acceleration. The third law, also known as the law of action and reaction, states that for every action, there is an equal and opposite reaction. This means that if one object pushes or pulls on another object, the second object will push or pull back with an equal force in the opposite direction. This law helps to explain how forces are transmitted through a system, such as how a person standing on the ground can push a heavy object by applying a force through their feet to the ground, which then pushes back on the object. Newton's laws of motion are important because they provide a mathematical framework for understanding how objects behave and how they respond to forces. They are widely used in engineering and physics to predict the motion of objects and to design systems that can withstand various forces.